Hello everyone. We will discuss electrostatics. Statics means charge is at rest. Charge is at rest. So we'll discuss electric charges and field. Then the first topic is Coulomb's law. Let us consider two charges Q1 and Q2. They are separated by distance r. So the expression of the force between these two charges is proportional to the charge Q1 and is proportional to the charge Q2 and is inversely proportional to the square of the distance between them. So that means force is proportional to Q1 Q2 by R square. If we remove this proportionality, we will put a constant. This is K. Q1 Q2 by R square. So from experimental evidences, from experimental observation, the expression of constant K is 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the force between two charges. So this is the expression of force between two charges. This charge Q1 and Q2 separated by distance R, where epsilon naught is where epsilon naught is called permittivity of free space. Free space or in air, and the value of epsilon naught is 8.854 into 10 to the power minus 12 coulomb square per Newton meter square, or sometimes we use as farad per meter, right? Then the value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. It will be Newton meter square per coulomb square. Then what is the dimension of 1 by 4 pi epsilon naught? So from this expression, we can easily write that 1 by 4 pi epsilon naught will be equal to f r square by q square. So dimension. So dimension of force, we know from Newton's second law, force is equal to mass times acceleration, which is equal to, and acceleration is length, velocity per time, and velocity is length per time divided by time. So dimension of force is mlt to the power minus 2. What about the dimension of the charge q? We know current I is equal to q by t, charge per time. So charge q is equal to current times t, and the dimension of current is ampere and time is t. So the dimension of 1 by 4 pi epsilon naught is equal to the dimension of force, which is m l t to the power minus 2, and the dimension of length is l to the power 2 divided by dimension of charge square. So a to the power 2 t to the power 2, which is equal to m l to the power 3 t to the power minus 4 and a to the power minus 2. So this is the dimension of 1 by 4 pi epsilon naught. Then what is the dimension of epsilon naught? So it will be simply inverse of this value, because this is in the denominator, epsilon naught is in the denominator. So if we write the dimension of epsilon naught, it will be inverse of this value. So it will be m to the power minus 1, l to the power minus 3, t to the power 4, and a to the power 2, right? Where epsilon naught is called permittivity. Epsilon naught is called permittivity of free space or in air. So this equation is called Coulomb's law. Now, in a medium, in a medium like wax, glass, or oil, let us say here is the medium, and charges are Q1, Q2. This is the Q1 and Q2, and they're separated by distance R. Then what will be the expression of force? So in a medium, force, the expression of force is equal to 1 by 4 pi epsilon Q1 Q2 by R square, where epsilon is equal to kappa and epsilon naught, where kappa is called dielectric constant, is called dielectric dielectric constant. So kappa is equal to epsilon divided by epsilon naught. That means this is a dimensionless constant. This is a dimensionless constant, and the value of kappa is always greater than 1. So the expression of force becomes force is equal to 1 by 4 pi kappa epsilon naught Q1 Q2 by R square. That means force is proportional to 1 by kappa.